Hey everyone, today we're going to continue on with chapter 14 and we're going to specifically focus on the stomach. So, a little bit intro and description of the stomach. It is a C-shaped organ located on the left side of your abdominal cavity. So, when you're looking at it, remember your abdominal cavity is a mirror image, so it appears to be on the right. It is actually almost hidden by the liver and your diaphragm. Food comes into your stomach through the cardioesophageal sphincter. Again, that's going to be located between your esophagus and your stomach. And then it empties out of the stomach into the small intestine through the pyloric sphincter. So, again, your pyloric sphincter separates your stomach and your small intestine. Now, there are different regions of your stomach. We have your cardial, also known as your cardia region. This is nearest to your heart and it surrounds your cardioesophageal sphincter. Then you have your fundus, and this is the expanded portion lateral to your cardiac region. So let's kind of go down to the picture and show that real quick. Here you have your cardia. This goes up into your esophagus. It's near your cardioesophageal sphincter. Lateral to it, so to the side, here this expanded portion that bulges out is your fundus. The body is the mid portion. It makes up the bulk of the stomach, and there are two curvatures, a greater curvature and a lesser curvature. The greater curvature is convex on the lateral surface, while the lesser curvature is concave on the medial. So if we look at it in the picture, your greater is lateral, so it's towards the outside. And then here, your lesser curvature is more medial. And then the last part of the stomach is your pylorus. This is a funnel-shaped terminal end. So if we're looking at it, your pylorus is right here at the end, and there's where you're going to find your pyloric sphincter. Now remember, sphincters are similar to valves. They help prevent backflow. So often when you think about it, up in your cardia region, if you ever have stomach acid go back up your esophagus, that's when you're going to experience a lot of heartburn. So you want that sphincter there and working so you don't experience that. Here is a real life image of the anatomy of your stomach. Here, this is where your sphincter would be, and then up here's your fundus. You have a main body, and then down here you have your pyloric sphincter and the pyloric region. Now your stomach varies in length from 15 to 25 centimeters, and its diameter and volume is going to depend on how much food is in it. In fact, the stomach can stretch to hold 4 liters or about 1 gallon of food when it's full. And the stomach is kind of special because it has little folds called rugae, and these are going to disappear when your stomach expands. And then when your stomach empties of food, it actually collapses and forms these little ridges. So here is your rugae of your stomach, pointing to all the different folds inside of it when your stomach's empty. Other parts anatomy of the stomach, you have your lesser and greater omentum. So basically what the omentum is it's part of your peritoneum or your covering, and it's just an extension of it. Your lesser omentum is going to extend from your liver to your lesser curvature, hence the name lesser. And then your greater omentum actually branches off of your greater curvature and extends down over your abdominal organs. Now, your greater omentum has a lot of fat in it, so you're going to see in the next slide that it has a very yellow appearance. This fat helps insulate, cushion, and protect your abdominal organs. Within this, there's also a large collections of lymphoid follicles that help with the immune system and get rid of any unwanted bacteria, virus, or foreign particles. Here, I got this picture off the internet because I think it does a great job to show where your two omentum layers are. For your lesser momentum, you're going to see up here on your lesser curvature of your stomach, it helps attach it to the liver. Down here, your greater omentum covers your abdominal cavity. You can spot it as yellow. It's like an apron and it kind of hangs down over those organs. Here's a real life picture of it. You can see the big, huge greater omentum. It's very yellowish. It hangs out and covers a lot of your abdominal organs. Unfortunately, you can't see the lesser omentum because it's hidden underneath your liver. So here you can kind of see your stomach, but the liver covers a majority of it. In terms of the structure of your stomach's mucosa or that layering, it's made up of mostly columnar epithelial. and it has a lot of mucus cells. And these mucus cells are very important because they produce a bicarbonate-rich alkaline mucus. In other words, what it does is it helps protect your stomach wall from being damaged by the very acidic environment of your stomach and prevents it from being digested by enzymes. If you actually did not produce this bicarbonate-rich alkaline mucus, or you didn't produce enough of it, that's where you're going to start getting ulcers where this acid is eating away at your stomach. Now, in terms of your stomach mucosa, there are other things on it besides just making mucus. It is dotted by something called gastric pits that lead to gastric glands. These, of course, release something called gastric juice. So hopefully you've recognized by now that stomach, the term associated with is gastric. Now, gastric juice has very, very important parts of it. There is the intrinsic factor, which is needed to absorb vitamin B12. There are also cells within your gastric pits. Chief cells and parietal cells are the two most important cells. Chief cells produce a protein digesting enzyme called pepsinogen, and parietal cells produce hydrochloric acid. This is what makes your stomach so acidic, but you need that acid, the stomach acidic, so that the HCl, hydrochloric acid, can turn the pepsinogen into pepsin. Then you have your enteroendocrine glands, and this produces something known as gastrin, which helps regulate digestive activities. Here's a picture of the anatomy. So you have your mucosal cells. Within you have gastric pits, and within the gastric pits you have your parietal cells that release your hydrochloric acid, and you have your chief cells that are going to release your pepsinogen. Here is just a closer up picture of your chief cells and your pepsinogen and your parietal cells and your hydrochloric acid. And here you have a formula. In order to convert into pepsin, you need that acidic environment. In terms of functions for the stomach, it is actually a temporary storage tank for food, and this is where a lot of mechanical breakdown also occurs. So your mouth breaks it down, but as it gets to the stomach also physically breaks down food by churning, mixing, and pummeling it into smaller fragments. There's actually a third muscle layer in the muscularis externa layer, and it is usually oblique. So we have our longitudinal, we have our circular, and now we have an oblique muscle arrangement. All the while that it's being physically broken down, food is also being chemically broken down as well. In fact, the stomach is the part where protein breakdown or protein digestion begins. Now, once it has broken down this food is known as chyme. So this is processed food. I'm going to be using this word chyme a lot, so please know that it is the same thing as just broken down food. And it moves this food into the small intestine. So if we talk about activities of the stomach, well, let's first focus on food breakdown. How is food made to smaller pieces? Well, gastric juice breaks down food and it's regulated by both neural and hormonal factors. So that can be things like the sight of food, the smell of food, and even starting to taste food is going to stimulate your parasympathetic reflexes. Specifically, it's going to stimulate your vagus nerve. And from there, the presence of food or rising pH is going to cause the release of a hormone gastrin. Gastrin also helps speed up the creation of gastric juice. It helps the release of protein digesting enzymes like pepsinogen. It also causes the release of hydrochloric acid to increase the acidity inside your stomach. And it also causes mucus production to increase to help protect your stomach from the high pH levels. Now, we already said hydrochloric acid makes the stomach very acidic. Why does it need to be acidic? Well, your stomach needs to be acidic because, again, it needs to activate pepsinogen into pepsin for protein digestion, and it also provides a hostile environment for microorganisms located on food. So, in other words, it kills bacteria, viruses, and other particles, foreign particles that cannot withstand that environment. Now, in terms of protein digestion enzymes, this is pepsinogen. Again, it's going to break down protein, so I'm going to go ahead and star that. Pepsinogen, protein. Also, another one that your book talks about is renin, and this helps digest milk when you're in infants. It digests milk where it gets this really curdy appearance. If you've ever seen a baby spit up, they're not spitting up sour milk. They're just spitting up milk that has been halfway digested. Now, at the same time that chemical digestion is occurring, please note that the stomach is still physically churning, pummeling, and breaking food apart to help aid in this chemical digestion. Now, we said that they do a lot of physical breakdown and chemical digestion, but please note that no absorption of the nutrients that have been released actually take place in the stomach walls. Really, the only thing that is absorbed in the stomach are things like alcohol and aspirin, but any other nutrients are not. After we have broken down food, then we have something called food propulsion. So remember, propulsion is the same thing as movement. So how does food move within the stomach and how does it move out of the stomach into the next digestive organ? Well, there are three major steps. The first step is peristalsis. We've talked about this before. This is those alternating contraction and relaxation of muscles that occur, and these always occur from the top of the stomach, from your fundus, all the way to the end of your stomach or your pylorus, and this peristalsis forces things through your pyloric sphincter. Now, it can only force so much through your pyloric sphincter, and then you hit the second stage, which is grounding or grinding. Your pylorus only lets a small amount of chyme, or otherwise known as food, into the small intestine. In fact, it only allows 3 milliliters at a time. That is a very, very small amount. The rest of it that was pushed towards that sphincter actually is forced back into the stomach, kind of causing a wave-like motion or churning. The reason for this is when the small intestine is full of chyme, its walls stretch and it causes something called an enterogastric reflexes. And what this does is it causes the pyloric sphincter to close. And that decreases your gastric activity. And since you can only release about 3 milliliters at a time, it takes about 4 to 6 hours to empty your stomach. So here's a picture that illustrates those activities within the stomach. Here, propulsion, you can see the contractions moving the food down towards your pylorus. When it reaches pylorus, it causes a little bit to go into your small intestine. So again, the pyloric at the end of the stomach acts as a pump and only delivers a small amount, and the rest of it gets propelled backwards, or retropropulsion, moves it back towards the stomach. So that's the end of the lesson. Let me know if you guys have any questions, and I hope you guys have a good day.